Okay, so we started looking yesterday into the latent heat. Today we look how to solve the problem. So let's consider the next situation. So again, we had that we had that how temperature changes when we add heat. Temperature, heat. So let's consider the next problem. What will be the temperature if we take 100 grams of ice equal 100 grams, so 0.1 kilogram, at the temperature negative 10 degrees Celsius. So temperature equal negative 10 degrees Celsius. And we drop this block of ice into the water with the mass of the water, let's say 1.5 kilogram, and temperature, initial temperature of the water is let's say 70 degrees Celsius. Question is, what will be the final temperature after ice melt and the temperature becomes the same across the whole world. So let's see what heat transfers happens here. First, what will happen with ice? It is at negative 10 degrees Celsius. It will melt at negative 10? No. So ice needs to heat up to negative, from negative 10 to 0 degrees. So first we calculate how much heat needed. How much heat needed to heat up ice from negative 10. That will be Q1. To heat it up from negative 10 to 0. So what formula we need to use? Where we are? On which part of this diagram? We are here, where we heating ice. It's not melting yet, we're heating C of ice times mass of ice and times change of the temperature. So the specific heat of ice, this table with it. 2093?
Yeah.
Okay, so we have 2093 times mass of ice 0.1, and what is the change of the temperature? 10 degrees, because it needs to be heated to 0 degrees, and that will be obviously equal to 1093 joules of heat. That's how much heat needed just to heat up ice from negative 10 to 0.
Do we have to write it in kilojoules normally, or can we just?
It really doesn't, depends how question asks you how to give answer. If question doesn't specify, you can give in joules, you can give in kilojoules. Now, what happens next with ice?
Latent heat.
It will melt. Yes? So then ice will melt. How much heat will be needed to melt ice? Which formula we using?
Latent heat.
Okay, times mass. Latent heat of the ice is latent heat of the ice. Latent heat of the ice is 334,000 because 334 kilojoules times mass times 0.1 equal 33,400 joules. So, to turn ice into the water to heat it up and melt, altogether we need how much heat? We need to add that much heat we needed to heat it up from -10 to 0. That much heat we need to melt it. So total to melt ice from -10, heat it up and melt, we will need 33,400 plus 2,093 joules. So will be 35,493 joules. That much heat needed just to melt an ice. Now, let's see what will become temperature of the water when it gives that much heat. Because heat, we consider there is no heat lost to surroundings. So all heat kept inside. As much heat ice receives, that much heat water gives. So we have water will be cooling down. So it will give up amount of heat, C of water times mass of water times change of temperature. And we take temperature final, which we don't know, minus its initial temperature 70 degrees. So equal 4,200, I will take rounded value, for the specific heat of the water, 4,200 times 1.5 times T minus 70. And that must be equal to how much heat ice get. So water cooling down, giving heat to ice heating up and melting. So we have that will be 6,300 T minus 4,200 times 70, 28. Can you check with the calculator? 294 equal 35,493. Can you please check for this?
Yes, it is.
No.
Yeah.
Sorry, no, I multiplied, we didn't multiply 6,300 by 70. No, that's wrong. I multiplied 4,200. We need to multiply 6,300 by 70.
Wow. It's 441,000. And yeah.
441,000?
30.
Yep, thank you. Now, does this make sense? How we get to here? Now let's find what will be the temperature of the water. So we rearranged it. We have 6,300 T equal. We add this, so 476,000. 493. So now we can find temperature. We divide 476,493 divide by 6,300.
It's
Please use your cal-
75.63. 75.63. That's what it says.
Mm.
Yeah.
Actually, something went wrong.
Mr. Mayor,
It
what's
can-
that number there?
Huh?
What's that number? You're at 6,300 T minus
6,300 T
minus, what's that number?
minus 441,000.
441. 441.
Mr. Big,
Yeah.
how does that equal 35?
That is how much heat ice gets. So the heat that change of the water, Cm final.
Oh, we didn't.
But then sorry guys, it's given heat. So what we need to do, we need to swap this.
So,
What a given heat.
so what's Q? What'd you get?
Heat.
No, it seemed like, what was the value of Q? How'd you get?
Because what is this? What is this?
Yeah, that's the,
What is this? What heat is this?
how much it took to get to zero.
To get, no,
I
just
get
heat
it.
up ice and melt.
And yeah.
And how much heat ice gets, that's much heat water gain. Yeah, so this has to be other way around. So it has to be minus plus. And so 6,300 T, because water gives heat. So we need to change in the equation, we need to swap 70 and T. Because water gives heat. And so if we rearrange that, we get 6,000, it will be 441,000 minus 35, so it will be 400,
Yeah.
6,300 T equals, you ready to tell the number? Hmm? You need this for 441 minus 35,493.
Isn't it flipped because there's a negative sign next to the T, so it's,
I move this
yeah.
to this side
Oh, yeah.
and this to this side.
Yeah.
So we minus in, if we minus 441,000 minus 35,493,
Negative 405,000.
no, not negative.
405, 507.
405,
507.
507,
No, 405, 507. Like 2 5.
405507.
Yeah.
And now we divide this, 405,507 divided by 6,300, and you have already 64.4 degrees. Have you solved the whole problem?
No.
No. We have found what will be temperature of the water just as a result of melting ice. And now what we have 100 grams of water at 0 degrees, and we have 1.5 kilogram of water at this temperature. And now they will be equalizing temperatures. Cold water will heating up, warm water will be cooling down. And as much water, how much heat will cold water receive? It will receive C, which is 4,200, times mass of the cold water, 0.1, and now change of the temperature, final temperature, minus 0. That's how much heat will cold water get. We have water, 100 grams of water at 0 degrees, and it heats up to the final temperature. How much heat it will get? Q equals C and change in temperature. Mass of the cold water, 100 grams. We have 100 grams of water at 0 degrees. Make sense?
Yeah.
And then water heating up from 0 to some final temperature. And that has to be equal how much heat the warm water gives. We have 4,200 times 1.5 mass of the water, and we have 64.4 minus final temperature. So how much heat the cold water receives, that much heat hot water will give. Heat received by cold water, heat given by, heat received by the cold water, heat given by the hot water, yes.
Now you said you used like 0 degrees. You found what it's at, what the ice is at 0 degrees. Yeah.
When we have ice heated up to 0,
Yeah, I know.
and then it melted, it turned into the water at 0 degrees.
So you have to do it from 0. You can't calculate from -10.
No, because we have change of state.
Yeah, that makes sense.
Because it was ice, now
So
it's
if it, was
water.
turning, if it also turned into a gas, then you wouldn't be able to use 0, right?
Yeah, then we need to consider the whole
Yeah.
process. Now we need to solve the 4,200 cancels out. We divide both sides by 0.10, that makes this 15. And we expand brackets, so final temperature equal 15 plus 15 times 64.4.
966.
966 minus 15 times final temperature. And we can now, so we have 16 times final temperature equal 966. So final temperature 966 divided by 16,
60.375.
60.4 Celsius. This is the final temperature. This is a big question. And it's important, but it's not hard if you follow the steps. Yes?
But the previous steps where you got like T equals 64.4 and stuff. Oh wait, never mind. You did it. No,
So let's again, I will sketch now flow chart. The steps, how you need to approach such complex problem. So we have ice at -10 degrees Celsius. This ice heated up to ice at 0 degrees Celsius. That's the first step. And we give some heat. Then this ice melt to water at 0 degrees Celsius. That's another, that's Q1, that's Q2. That's what's happening with ice. And we're calculating how much heat ice receiving. At the same time, we have water at 70 degrees. And that water cooling down to some temperature. That's Q3. And that Q3 exactly equal Q1 plus Q2. So we have heat that needed to heat ice, heat plus heat needed to melt ice, exactly equal how much heat water gave. And we found that water cools down as a result of this to what temperature? 60, what was the first we calculated? 64.4. So that much heat water gives, and it cools down from 70 to 64.4. And that heat was enough to heat up the ice and melt it. Question? If you have question, please ask. Which step?
You said, I don't understand that second, I understand the first line, I don't understand the second line.
This, you don't understand this or this?
Yeah, no, that one. Yeah, why does it just go down, like what's?
Because we have hot water and it given energy to heat to the ice.
asking for when
So
you
it's
get
cooling down. It's given.
Yeah.
And exactly, we consider no loss of the heat to surroundings, so we consider as much heat hot water gives, that exactly much heat ice receives. Yes.
Wait, so guys, you have to find the water 0 degrees. I thought it was,
The ice, when it's melting, temperature stays the same. Temperature stays 0 degrees until all ice melts. It's not increasing. It will start increasing only when all ice melts.
so it only got to 0 degrees because it's only.
Because ice melts at 0 degrees. Now, we have second stage. We have water at 0 degrees, and we have water at 64.4 degrees. And they both, this will give heat, Q4, Q4. I write same number because as much as heat the hot water gives, that much heat cold water receives. And we equalize those amounts of heat. Cold water heating up, hot water cooling down. And we found that because this was 1.5 kilogram, this was 0.1 kilogram, that the final temperature of the water was, can you remind me, 60.4 degrees. So when this water heats up, this cools down, and at 60.4, the temperature of the all water becomes the same, 60.4 degrees. Now, no heat transfer continues. Yes?
How do we know the mass of the final build?
If you have 100 grams or 0.1 kilogram of ice, it will turn into the 100 grams of water.
It doesn't change.
Volume change, but not the mass. Ice expand, when ice melts into the water, it takes less space. That's one of very unique situations. When in the solid state, it has less density, so turning to the water, it's actually, water is more dense than ice, so it's gonna, but mass stays the same. Makes sense? It's pretty much sort of a hardest type of question. Using because we need to consider all heat transfer. Always solving problem, consider, make a flow chart. What's giving heat, what's receiving heat. And it always will be heat received exactly equal heat given. Okay, now will be time for you to do some practice questions. Yeah, and of course, like, subscribe, and donate to Ukraine to help to fight Russian aggression. Link in the comments.